All right, let's continue on with the lesson. Lesson 6.6, the fundamental theorem of calculus part 2. So this is like the mountain, the top of the mountain, where we started coming from derivatives, and we got integrals, and this is where they meet. So the question, how much distance did we travel from A to B when we only know the derivative of f, when we know only the velocity? So the velocity of that function, say we have here from A to B, and it didn't have a constant velocity. It changed, it kept changing as it went. So what would be the distance traveled with something that does not have a constant velocity? So the distance between A and B of that f function, the antiderivative of this, would just be the area under the curve of this. So if this is the v of t function, and we can find the antiderivative function where it came from before it became that, then we could just plug in f of b minus f of a and find how much distance it has traveled. But it's also the area under the curve from A to B. So how much distance that f function or whatever that other function was is the area under this curve here. So if we can just find the antiderivative of v of t and then evaluate the function f of b minus f of a, then we would know how much distance it has traveled between A and B. So f is the antiderivative of v of t. And so when we do this, then we have answered also this other question, the question of area under the curve. What is the area under a curve that is not like a rectangle or a triangle or a circle or anything, but it's not even shaped? We have found the exact area under the curve of v of t from A to B. That blue, the green area right there would just be f of b minus f of a. just to continue, you guys can go back and copy down this on the website. Let's go ahead and do some problems now. So the area under a curve, if we can find the antiderivative of whatever this is, then we just evaluate it on from the upper, subtract the lower bound. And that's what we're going to do now. Problem number 3. What is the area under the curve of y equals x squared from x equal to 0 to x equal to 1? This is how we started chapter 6, where I said a long time ago, you have the x squared function, and then they were asking what's the area from 0 to 1? What is this area here? And they would be doing rectangles, right-sided Riemann sum or whatever of however many rectangles. All right, 5, 1, 2, 3, 4, 5, and you take the limit as the rectangles become infinite rectangles, amount of rectangles there. All right, so what is this area here? Well, now we can just do it by doing the integral of it. And so we're just gonna find what's the integral, what is the area? So area will equal to the integral from 0 to 1 of x squared dx. So what is the antiderivative of x squared? If x squared is the derivative, what is its antiderivative? Where did it come from? This is the derivative. So where did it come from? Anybody? What was this? What's the antiderivative of this one, you think? Meaning that if you take the derivative of this, you get this. Take the derivative of this, you get this. What is this? It would be x cubed, yes, yes. And what else? 1/3 x cubed is correct. That is correct. Because if we take the derivative of this, that would be, bring this, so it would be 3 times 1/3 and x squared, and this cancels x squared. So how do we find antiderivative of like power, like x squared? You would just add 1 to it, and then put the number under it. 2 plus 1 is 3, and then put it under it. So x cubed over 3. You add, and that same number, whatever that one number on top, that you put at the bottom, and then you evaluate. We say we're going to evaluate this from 0 to 1. And so so evaluate it. We go from the top, from the upper limit, subtract the lower limit, plug it in. So x is 1 to the 3rd power over 3 minus x is 0 to the 3rd power over 3, which is just going to be 0. So 1 to the 3rd power, what's 1 to the 3rd power? 1, so it's 1/3, and that is the area under the curve. The exact area under the curve. All right, let's just continue on. Okay, so how do we find antiderivatives of like third degree function? This is a cubic function. Pretty straightforward how to find antiderivatives of this. This is called a definite integral. Why is it called a definite integral? Because it has a lower and upper bound, and we can evaluate and actually get an answer. All right, so for this first part, the integral for x cubed, so we're gonna what? Add 1 to 3, so be x to the 4th. Put that 4 at the bottom. We have a 4 on top there already. So then we're gonna plus 2 plus 1 is 3. And then put that 3 at the bottom. There's the 9. I'm not changing colors. And then minus, and that's a constant. It came from 5x. Put the x back. Negative 5x. All right. So we can cancel x to the 4th plus 3x3 minus 5x. Evaluate it from 3 to 5. Plug in. Probably calculator work. Let's do it, but just so be what? 5 to the 4th plus 3, 5 cubed minus 5 minus put this in a calculator. 625, 125 times 3, 1 was 375, 375, minus 15, well, hold on here, why did I put a 3, here? Why did I put a 3 here? 25. I'm gonna minus 81. 81? Yeah, 81. Minus 15. Man, calculator. Calculator. Take out your calculators. 625 plus 375 minus 25. 975. 975 minus 162 minus 15. That's positive, so 147. 975 minus 147, 828. I don't know, is it? Oh, All right, so that's the idea of this. Okay, let's go to 5. So sometimes you have to think a little more. Before you integrate. What should we do? If we can just do it like that. What should we do? What should we do, anybody? Come on. Couldn't we divide x into that or into that or like cancel? Oh, you can factor out an x, no? Let's factor out an x on top, no? So it'd be what? X minus 1. And now you can cancel out the x. If that's better. Yep. And now we can integrate x squared over 2 minus x. Negative 1 to 1. It's going to be 1/2 minus 1 minus 1/2 minus a negative 1. Negative 1/2 minus, that's a plus plus, that's 1/2, 3/2 minus 3/2, and that's going to be minus 4/2, which is minus 2, negative 2. All right, let's go to 6. What's the antiderivative of that one? ln x. So then this is just going to be ln x from 3 to 6, ln 6 minus ln 3. I mean, the properties of logs, you can go to 1 log, ln 6 divided by 3. When you got 2 ln's, you can go to 1, 6 divided by 3, minus divide, 6 divided by 3, so it's ln 2. Redundant here. I don't know, whatever. X to the 4th over 4 minus 6x squared, whatever. Alright. That's it.